Dear students, welcome to another session of programming using C language. Myself, Harsh Bansal, Assistant Professor from Computer Science and Engineering Department, Chandigarh University, Garhwa. In this session, we'll learn about the basic elements of C programming language. Takeaways from this session are: first, tokens, which are the basic building blocks in C language. Identifiers, which help identify data and other objects in the program. Next, keywords, which are reserved set of words that cannot be used as identifiers. Basic data types in C, namely character, integer, floating point, double, and valueless. Variables, which are defined as meaningful name given to a data storage location in computer memory. So let's get started. Now, as you can see here on the screen, that when we begin to learn English language, we first started up with the alphabets, right? And then we use those alphabets to construct words. And then gradually words were used to construct sentences and so on, paragraphs, right? Similarly, when we talk about C programming language, we use alphabets, digits, symbols to form constants, variables, and keywords, right? Now, these constants, variables, and keywords are further used to create meaningful instructions. Set of instructions, when combined together, they create a purposeful program meant to give solution to a problem or task in hand. Right? So let's understand what tokens are. Now, token is a smallest element of a program that is meaningful to the compiler. A token can be classified as keywords, identifiers, constants, strings, special characters, and operators, which we'll discuss further in detail in this particular session. Talking about keywords. Now, keywords are a set of reserved words, right, which have a predefined meaning. Now, they cannot be used as identifiers. They cannot be used as variable names, because if you try to do so, you are trying to change the meaning given to the keywords, right? So these are reserved ones, right? So they have a specific functionality to perform, and we do not manipulate the meaning of the keywords as given to the compiler, right? So we have a total of 32 keywords in C programming language. Moving on, identifiers. Now, talking about identifiers, these are basically the names given to program elements such as variables, arrays, or functions. So they are generically defined as identifiers. Now, whenever you name variables, whenever you name arrays or functions, there are a set of rules which must be followed. The very first rule is that the name must begin with a letter or an underscore. They must contain only letters, digits, or underscore. No other special character is allowed. And very important, it should not be a keyword. And the naming convention does not allow us to use white spaces in between. And the maximum length of a identifier can be maximum up to 31 characters. All right. So moving on, next what we have is constants and variables. So talking about constants and variables, as you know, that constants are entities that do not change, whereas variables are the entities that may change, right? So constants are also like normal variables, but the only difference is that their values cannot be modified by the program once they are defined, right? Constants refers to fixed values. They are also called as literals, right? So constants may belong to any of the data type. Now, whereas when we talk about variables, very important thing is that why we need a variable, what is the purpose of the variable. If you understand in layman terms that variable name is just a meaningful name or a name given to a storage area that programs can manipulate. Let me define you in layman terms. For example, we all have house addresses, right? But we find difficulty in remembering the house addresses. But we can easily remember the house address via the name of the person that lives in that particular house, right? So exactly that's what the context is, right? We have memory addresses, but memory addresses are very difficult to remember as we compare addresses to our homes, right? So we give names to those memory addresses, and those are basically our variable names, right? So a variable definition tells the compiler where and how much storage to create for the variable, right? It does not just give a name to the memory location, but it also tells that how much space is required, to store the values within it. And that is defined with the help of what we call as data types. So like in mathematics, you just used to write x is equal to 10, but over here we don't do that. We also add a data type to the variable, right, which also defines um, how much memory is required by the variable, right? And variable would further then would point to the memory location. All right. Now we have two different types of variables over here. We have numeric variables, right, which are used to store integer values or floating point values. Another type of variables which we have over here are character variables, which are specifically used to store letters, right, like A, B, C, right? And most importantly, we can also store um, uh, values from 0 to 9 as well, right? But there is a difference. Now you might say, so how 0 to 9 would be a character, why it's not an integer? Please understand, whenever you store character variables, they are stored in single quotes, right? So if you store 0 in single quote, that would become a character variable. If you store 0 without single quotes, that would become an integer variable, right? Or a numeric variable. So further, what you need to understand is, while you have stored a 0 in single quotes, 0 would further be mapped to an ASCII value, right? Every character value has an ASCII value, right? And which then will be translated into the binary format of ones and zeros. So what are the various basic data types we have in C, right? We'll discuss now. Now, as I have already told you, that data types determine the storage requirements of data elements. So we have various data types, namely character, integer, float, double, and valueless. Let's discuss about these data types one by one. The very first one is character. It stores a single character and requires a single byte of memory in almost all the compilers, right? Please understand, it can only be used to store single character. You cannot store more than one characters, because otherwise it will become a string, right? And just to give you a difference between a character and a string, characters are stored in single quotes, whereas talking about strings, those are stored in, or they're stored using double quotes, right? So a character constant is a single alphabet, it could be a single alphabet, it could be a single digit, or it could be a single special character, right? Or a single special symbol, right? Enclosed within single inverted commas. Is it clear? And let me throw one example over here. As you could see, the ASCII table, right? If you look at capital A, right? If you store capital A in single inverted commas, right? Now that will be translated to the ASCII value, which is 65 at the back end, right? And then which will be further then converted into the binary format. As we know that everything is stored in the form of ones and zeros, right? So we need a mechanism, right, to translate these character values, right, into binary format. And that has been done with the help of what we call as ASCII table over here, right? So ASCII table are basically provides us with the standard codes. Now over here, A has a standard code, which is 65. Talking about other data types, for example, integer. Now that is basically used to store an integer value, a whole number without a fraction part or a decimal point, right? It can be either positive or negative. By default, it is assumed to be positive. No commas or blanks are allowed within an integer constant. Allowable range depends upon the compiler, right? It could be 2 bytes or 4 bytes. Usually 16-bit compilers, uh, you know, uh, take a size of 2 bytes, and 32 and 64-bit compilers uh, reserves a space of 4 bytes. And the range then varies accordingly, right? We'll discuss about range more in depth in our next session. So hold on to that. Next, what we have is we have floats. So floats are used to store a decimal number with single precision, right? Now, floats take a size of 4 bytes. If we say 4 bytes, that means it takes 32 bits, because 1 byte has 8 bits. So 4 bytes will have 32 bits, right? So 32 bits are reserved, wherein 23 bits are used for the value, 8 bits are used for the exponent, and 1 bit is used for the sign, whether it is positive or negative, right? So floats has a 6-digit precision, which means we can use up to 6 digits after the decimal. Otherwise, it will truncate anything after that. Moving on, talking about double. Double is used to store decimal numbers with double precision. Now, double takes 8 bytes, right? If we say 8 bytes, it will become 64, right? 64 bits. Now, how do we use 64 bits? Out of 64 bits, we use 52 bits for the value, right? 11 bits for the exponent, and 1 bit for the sign bit, right? And another we have is void, which is valueless, and it holds no value. So why do we use void where it is helpful? So void is basically used as a return type for the functions, used for specifying the parameters within the functions, and is also used with pointers, right, to define a void pointer, which you'll learn further in this particular course, right? So void has its own significance. Moving on. Yes, this we have already discussed. So this is the ASCII table. ASCII table stands for American Standard Code for Information Interchange, right? And it includes a description of the letters, numbers, special characters, and there are some control symbols as well, as you could see, right? Each character is assigned a unique 7-bit code, right? So the ASCII codes could be further translated to a unique 7-bit code, right? Now, moving on, along with the data types, right, we have modifiers. We have two different types of modifiers. One are size-based specifiers, and another are sign-based specifiers. If you talk about size-based, they are basically categorized as short and long. And if you talk about sign-based specifiers, we categorize them as signed and unsigned. Now, why do we have them? Now, let's try to understand. As I have already told you, let's take the example of integer, right? Now, the size of the integer depends upon the compiler. 16-bit compiler used to allocate 2 bytes of memory, right? And the 32-bit and 64-bit compilers allocate 4 bytes of memory. Now, if we want to, manipulate, if I want, let's suppose I'm using 16-bit compiler, and I want to increase the memory which is allocated to integer, then I'll make use of the modifier. I'll make use of long specifier along with the integer. So I'll write long int, right? And that would manipulate the memory within the compiler. They'll start, reserving 4 bytes of space within the memory. And similarly, if we are using 64-bit compiler, now by default integer takes 4 bytes. And if I know that I don't require that much of space, right? When I say space, that is basically the range, right? When we know that what will be the range of the values which we are going to store within the variable, right? So if we know that we don't require 4 bytes, right, and 2 bytes would be enough, now in that case, we'll make use of short int in 64-bit compiler, and in that case, it will reserve 2 bytes in the memory. Next, what we have is signed and unsigned. Now the numbers could be positive or negative, right? By default, when you write int, it is basically signed int. When you say signed, it means it can be both positive as well as negative. But if you know that the value is gonna be only positive, there won't be any scope of negative values. So you will rather consider using unsigned along with the integer. Why? Because in that case, it will increase the range, right? For as you could see here in the chart, that integer is has a range of -32768 to 32767, right? But if you make it unsigned, the range, because now we are storing only positive values, right? So the range would become 0 to 65535, right? Gradually, we can store some more positive values. And how does this range computed? We'll learn more in depth in our next session, right? Moving on, I'll demonstrate some of these concepts, that what is the size taken by the integer and how do we determine the size taken by the integer. I'll take you to the compiler for the demonstration. Let's move to the compiler for the demonstration. Let's start writing a very basic code over here. So we write hash include stdio.h. So this is our header file, standard input output header file. And then we have int of main. Now within this, we'll define variable types. So I'll write integer variable, right? Or just write integer variable. Let's suppose it has been given a value of 10. Then we have float variable. So I'll write float var, which is given a decimal value. Let's suppose 3.14, right? And similarly, we can have character. So char variable, which is storing a, And further we have double, right? Double wherein we are storing 3.14 again. And next, what we have, we won't be demonstrating valueless because it's usually used with generic pointers or used as a return type within the functions, right? So these are the data types we have. Now, if we want to see what is the size taken by each of the data type in this particular compiler, for that we'll use printf statement. And within the printf statement, we'll make use of formatted specifiers. We'll discuss formatted specifiers more in depth in further sessions. But for a while, let me just tell you that the size is basically um, uh, would be an integer value, right? Because int will take 2 or 4 bytes, float will take 4 bytes, char will take 1 byte, double will take 8 bytes, right? So these are basically integer values. So, and there'll be unsigned integer values, right? So for that, we'll use format specifier accordingly. I'll write the size of integer variable, the size occupied by integer variable is percentage LD, and here I'll make use of size of operator to compute the size of the integer type variable. So I'll pass integer. So this is our very first statement, right? And with this, we'll pass some more statements, right, to compute the size of float variable, right? And let's write float. Yeah. And similarly, we can have a character variable. We'll write of that. And then we'll have a double variable. So this will give us the size which is occupied by each of the variable. Let's check this out. All right. So here we'll get the output. Let's wait for the output. So you could see that the size which is occupied by integer variable is 4 bytes. So the size allocated is in the unit of bytes, right? Make a note of this. You can change the statement. You can make the output statement much better by using bytes by hand. So let's rerun this, right? So now this is a better output. So it says the size occupied by integer variable is 4 bytes. The size occupied by float variable is 4 bytes. The size occupied by character variable is 1 byte, and double variable is 8 bytes. You can also make use of the modifiers. You can make use of short, long, unsigned, signed as well to determine what is the size. I'll leave that to you. And also, just to mention that if you want to print an integer value, we use %t as the formatted specifier. So let me use a comment. So we use %t for %t as format specifier integer, right? And for float, we use %f. For character, we use %c, and for double, we use %lf. L is in small, right? So let's print the value of integer, float, and character of all these variables. To do that, what you'll do, you'll write printf value of integer variable is %t. So what you'll write, the value of integer variable is %t, because we are printing an integer value, right? So you'll pass integer variable over here. So whatever is the value stored in the integer variable will be, placed instead of the formatted specifier, right? Next, what we have is we have float variable. So we will use %f for the float variable. The value of float variable is %f, and pass the float variable over here, right? Similarly, to print the character variable value, you'll write the value of character variable is %c, and pass char variable, right? Similarly, to print the value of double, we'll have double variable, right? And here you'll use lf as the format specifier. We'll discuss about format specifier more in depth in our next session. But as of now, just to tell you that how to print the value of the variables, the value of the variables, what you have to use, you have to specify the format specifier. So %t is the format specifier for integer, %f is the format specifier for float, %c is for char, and %lf is for double, right? And you can see the output over here, right? So this is our output. I hope you have now little clarity about what data types are, how we write a variable with the help of the data type, right? And how we print the value of these variables using formatted specifiers. Also, how we can determine the size occupied by any data type with the help of size of operator, right? So let's move back to our presentation where we left. Now, this is what you have learned in this session, that every word in a C program is either a keyword or an identifier. C has a set of reserved words, often known as keywords, that cannot be used as an identifier. The basic data types supported by C language are character, integer, float, and double. A variable is defined as a meaningful name given to a data storage location in computer memory, right? We refer to the addresses of the memory where the data is stored using the variables. And most importantly, the difference between signed and unsigned numeric variable is that signed variables can either be positive or negative, whereas your unsigned variables can only be positive, right? By default, if you define integer, that will be considered as signed. So I'll leave you with some questions. Try these questions out, and we'll pause the video for a while, and we'll discuss the answers at the end of this particular session. So this is the very first question. which asks that which of the following is not a character constant. Have these options. Pick which of the following is not a character constant. So you need to remember that how we mention the character constants, right? I hope you remember that which does not basically follow the rules to define the character constants. It's a very easy one. Let's move on to the next question. Identify the invalid variable names. So you have to find out invalid variable names. There could be more than one invalid variable names. You have to figure out all the invalid ones. Next question, is variable name defined as marks considered same as marks? Yes or no? And the last question is, are keywords case sensitive? So I hope you have thought of the answers or written down the answers on a paper. So if not, you can pause the video. Otherwise, let's discuss the answers to these questions. Now, the answer to very first question is that which of the following is not a character constant? Definitely the answer is B. Why? Because it's mentioned in double quotes. And if it is mentioned in double quotes, it will be considered as a string, right? So whenever you are writing character constants, you need to be sure of that you are writing in single inverted commas. Identify the invalid variable names. So what are the invalid variable names? First dot name is an invalid variable name because you cannot make use of dot. A plus B is an invalid variable name because you cannot make use of plus, right? Dollar amount is an invalid variable name. Similarly, you cannot make use of dollar. Underscore floats is valid because the underscores are allowed and variable names can start with underscore as well. But there cannot be two successive underscores. Please make a note of this. Is variable name defined as marks considered same as marks? No, because they will be considered as two different variable names. And just to point out, C programming language is case sensitive. So are keywords case sensitive? Definitely yes. So these are the answers. We'll continue how to compute the range of the data types in our next session. That'll be it from my side. Thank you.